Hey guys, welcome back to another episode of robotics. So today what we're going to do, I want to dive in a little bit deeper into resistance and voltage. Now we want to do that because we want to learn how to use this component right here. This is a special resistor that is light sensitive. Okay, as light shines on it, the resistance actually changes. All right, so we got to learn about how that all works so that we can use light to control our robot. All right, so the first thing we want to do is check out the whiteboard here. I'm going to draw the symbol for a resistor. So here we go, resistor, okay. And in this situation today, we're going to use actually two resistors. We have one resistor here. We're going to connect a second resistor to the bottom of it. We're going to stack it like that. We're going to connect the top side to the high voltage, which is 5V, 5 volts, and you're going to find those connections on the Uno has two 5-volt connections. And then the bottom resistor we're going to connect to 0 volts, which is the same as G and D. Okay, and we have a bunch of G and Ds here on the Uno. Now you notice I drew a circle here. So the intersection, the connecting point between the two resistors, we're going to connect that to A0. Okay? So even before jumping into explaining what's going on here, let's go ahead and connect this up. Okay? So let's get a resistor, and we have we're going to use this one here, the 10 kilo ohm resistor. All right, so that's going to be the top one. So looking back on the board, 10 kilo ohm resistor. So one side connects to 5V. So let's go ahead and do that. And actually I had a wire that came out. So hold on, I'm going to fix this really quickly. My ultrasonic sensor had a 5V connector that got pulled out somehow. So I'm going to put that back. Okay, so this wire right here is already 5V for my ultrasonic sensor. So I'm going to go ahead and take my 10 kilo ohm resistor and stick one side into that same row. The other side, I'm going to just make a new row over here. All right, and then I'm going to get my photoresistor, this thing here. And we notice here, I'm going to just write the word PR. Okay. The photoresistor also has two legs. So one side we're going to connect to the 10 kilo ohm resistor. And then the other side is going to be connected to, if we look at our schematic, the other side goes to 0 volts or GND. And that's, for me, the buttons connected to G and D right here, this row. Now yours might be connected in a different manner, and that's totally fine. I'm just trying to save wires here so I don't have to get out extra wires. Okay, so here's my connections. So, and my photoresistor is right here. Now I also need to connect this A0 thing. And I'll explain what this A0 thing is in a second. So let's get this. I'm using yellow wire, and one side connects to the same row as the photoresistor and 10 kilo ohm resistor. So there's going to be three things connecting in this row. So I'm going to stick it in. And then the other side is going to go into A0, which is right here. You're going to see analog in up there, and then just stick it into A0. Cool. There we go. So we're connected in. Let's talk about how this thing is going to work. All right. So going back here, we have two resistors, right? We have the 10 kilo ohm resistor, which, you know, we've used resistors in the past. Basically, resistor, what does it do? It blocks electricity. Another way to think of it, it eats up electricity. And then when it eats up electricity, it creates something called a voltage. All right. Now, the 10 kilo ohm resistor is pretty simple because it's always going to be 10 kilo ohms. And then what happens is as electricity comes out into the 10 kilo ohm resistor, it creates a certain voltage. Now, the photoresistor, it's a little bit different. It's not a 10 kilo ohm resistor. And I'm going to create this, just write this symbol here, okay? This symbol here represents that this resistor here actually changes. Okay, what does that mean? Sometimes it can be like 1K. Sometimes it can be like 100K or even greater. I'm kind of making these numbers. The idea is that sometimes it can be really small and sometimes it can be really big. Okay? And then that resistance, again, that's changing. When electricity goes through it, it creates a certain voltage. Okay? So we know that when electricity goes through the resistor, it creates a certain voltage. And then we also know that the photoresistor, sometimes it changes voltage or it changes resistance, and then it uses that changed resistance to create a voltage. So first thing, how does it change resistance? How come sometimes it's like 1 kilo ohm, sometimes it's 100, or like I said, even more? How does it change? Well, it changes by light. Okay, so this area right here, if we look at the photoresistor, is just this white thing with red squiggly lines on it. Okay, that if we shine light on it, the resistance actually goes down, becomes small, becomes like 1 kilo ohm. And if you cover it, like put a blanket over it so it's all dark, the resistance becomes bigger, something like 100 kilo ohms or even larger. Okay, so that's how we control the amount of voltage that comes out. All right, the bigger the resistance, like when we make it dark like that, the bigger resistance, the bigger the voltage is going to be. When we shine the light and make this super bright, like if I took my phone and had a flashlight, shine it super bright, the resistance would go down, and that would also make a smaller voltage. All right, so those are some concepts for you to think about. Now let's talk about this A0 thing. So I'm going to erase some of this stuff here. Okay. Now, what is A0 about? I want you to think about A0 is like an elevator, okay? And then 0 to 5 is like a building. These are like the windows in the building, okay? So the high voltage is 5, or the highest floor is 5, and the lowest floor is 0. All right, so when we're in this, you can't go past 5. You can't, like, imagine a building, you can't go through the top floor, right? You can only go to the top floor or the bottom floor. That's it. Okay, so same thing with A0. So A0 is the elevator. If I want A0 to go up high, so this is how do I do that? So I'm gonna erase some of this stuff. Okay, so if I want A0 like up here, what needs to happen? What needs to happen is that the bottom resistor needs to be super big, okay? And then the small resistor needs to be smaller than the super big one, like that, okay? If we do that, then the A0 is kind of boosted up, and it's gonna go up high. Now the opposite is true. If we wanted A0 down here, let's erase. If we want A0 down here, we need a small here, and then we need a big one up top to kind of push it down, right? All right, so the size of the resistors, that controls where A0 goes, okay? If the top is bigger, A0 gets pushed down. If the bottom is bigger, A0 is pushed up. Now let's talk about our situation here, okay? Our situation is that this one is always 10 kilo ohm, right? That's not going to change. If you shine light on this resistor here that I'm pointing with my finger, if you shine light on it, or make it dark, it won't change the resistance. So that one can't change. The size can't change. But what can change is the bottom one. I'm going to draw our A0 connection here. So basically what's happening is when if I cover it, let's see, if I cover it and make it dark, my photoresistor here becomes super big, right? And if that happens, A0 gets pushed up. If I shine light on it or put it really close to the light, like imagine my camera's a light and I put it really close to it, or I should take my camera and shine light on it like this, my flashlight. So if I do that, then it becomes really small like that, smaller than the 10K. And then what happens, since this one's bigger, is going to push A0 down. Okay, and so that's what's gonna happen here, right? So 10K doesn't change. The photoresistor, the PR here, changes, becomes big or small depending on whether or not I shine the light. So we're going to use those facts to now control our robot here. All right, so let me go to our code here and see what we can do. All right, the first thing I want to do is I'm going to use a serial monitor. I want to use a serial monitor to read out the A0 elevator. Okay, what is the A0 elevator again? It's this right here with my mouse. I want to see if A0 is going up or down depending on the light. So I want to first make sure that that works. All right, so I'm going to use my serial monitor. So I need to do serial.println analog read A0. Okay, cool. And I'll put a little delay in there so it doesn't keep on reading too fast. Analog read A0. And I also want to make sure I did the serial.begin. So I go to my setup. I think it's at the top here. Setup. Serial.good. I have it. So we want to make sure we have serial.begin 9600 in your void setup function. Otherwise, the serial monitor won't work. All right. So going back down, so we know what we're running. It's just going to read analog read A0. And we use analog read. That's a newer command right now. And that's to read these analog pins here. So you could write A0 through A5, but since we're stuck our pin into A0, we're going to say A0. All right, let's upload, see what happens here. Cool. And let's do the monitor. Okay. So right now, it says about 106. Cool. And then if I put my finger over it, oh look, it becomes 350. So like that's 106. I put my finger on it, 350. And what happens if I have a little lamp here? What if I turn off my light? Becomes 180. Huh. So let's write that down. I think I forgot already. So 180 when the light's off. When the light's on, 103. Okay, so let's write that down so I don't forget. So challenge 1. Find out A0 levels for light on, light off. So for me, light on is like, was it 1? I have to double check. I think light off was 180. Let's go back there. Yeah, 180, and then light on was 102 for me. Cool. Okay. Now for you, it might be different, right? So your resistor might be a little different. The brightness of your lights in your classroom may be different. So you can't just take my numbers. You got to figure out yourself. Okay. Let's also figure out if you have access to it, a little flashlight. What if you go right up to it, like super bright? Oh, I see. It's like becomes 38 or something. So I'll say super bright. This is like 38. Okay, let's put these in order. So super bright, light on, light off. And let's do also full darkness. What is it? So when I put my thumb, my finger over it, what's the number for A0? 547 or something. Okay, great. So now that I have these numbers, I can try to do something with them. So my challenge 1 is or 2, move car when light is on, stop when light is off. So when I turn on my lamp, I want it to move. Turn off the lamp, stop. So let's see. So light on is 102. So I'm going to say if it's 102, or I'm going to say if it's 100 or greater, I want to move. Is that what I want to say? I want to say 100, or you know what? I'm going to give it a little margin. So the way to think of it is between 102 and 180, it's kind of like, is it on or off, right? So I'm going to say if it's 110, or less, I'm going to move forward. All right, let's try that. Going back to my code here. If analog read A0 is less than 110, I'm going to move forward. And then else if analog read A0 is greater than 110, then I'm gonna stop. Okay, now the reason I didn't write just move forward, I just wrote the comment here, is because my move forward has this inches in it. I don't want that. I just want it to move forward forever until I stop it. So I'm gonna make something new called move forward no distance, int speed A, int speed B, right? And I'm just gonna copy these two. So I'm not gonna be worried about like how many inches I want to move or anything like that. I'm just gonna move forward. Okay, copy that and put it right here. I still need to put my speed. I'm gonna put 200 for speed. Okay, so this should work, I hope. Let's upload and see what happens here. And what I can do is look at the monitor too to see what values are coming out. Okay, so 180 right now. So my code says if it's less than 110, it's going to move forward. So I'm going to turn my light on. Here we go. Totally working. So turn my light on, stop. So I'm controlling it by light. Pretty Pretty cool, right? So now when I turn the light on, the car moves. When I turn it off, it stops. That's interesting. Once we have that going, we can just do some different things, right? Move forward when light is on. Move backward when the light is off. So that's just like a simple challenge, kind of just to get warmed up. Okay. And then after you kind of get that, you know, the basics going, I think it would be kind of cool if you can do something like this. Okay, so push the button, then the car moves forward. Okay, so we've done that before. You just press the button and then the car moves forward. And then whenever you shine a light on the photoresistor, turn right. Okay, so you push the button and then it's just going to go straight. Okay, and then you take a light, maybe it's a cell phone, maybe it's a flashlight, and then whenever, oh, it's using my code from earlier, right? I'm shining it and it's going. So, but it's moving forward, and as you shine a light on it, it turns to the right. Now, what's the use of that? Well, the cool thing is that you're now able to kind of control it. So let's say you're trying to make it go around a desk or something. You can just tell it to go straight in program, but then when you need it to turn, you just shine a light and it'll turn. Shine a light and it'll turn. Okay? So that's just to give you an idea, like you can add light sensing and control your robot using a light. So it's a cool little feature that we can add, and at the same time we're learning about, you know, voltages and resistors. Before I sign off here, the last thing that I want to say, this circuit here, what we've created to create our light sensing for our robot, is actually called a voltage divider. Okay, so it's a common circuit in electronics, a voltage divider. The reason it's called that is because we're using 2 or more resistors to divide the voltage. Now sometimes it's divided, the voltage is divided exactly in half. That's like when A0 is at the halfway point. But it can also mean that A0 is either down here or up there, and we learn that the A0 position, like what floor it's on of the in the voltage building, depends on the size of the resistors, right? So the point is, a lot of times in electronics, you want to control the A0 to do different things, which is right now we're using it for light sensing. And the way that you control it is by changing the resistors, changing the resistance of the resistors, and it's called a voltage divider. All right, so I'd like to throw in some engineering terms in there. You don't really need to know anything beyond that. It's just that the thing we made today, it's called a voltage divider. All right, that's all we have. Have fun with the challenges, and we will talk to you later.